Hi everyone. Today we're going to be looking at our notes on factoring polynomials, particularly factoring the GCF, or greatest common factor, out of polynomials. To start, I want to take a look at factor trees. Factor trees are ways that we can find the prime factorization of numbers. So taking a look at 36, we can see that 36 can be broken down into its factors 3 and 12, where 3 is prime, and 2 can be and 12 can be broken down into its factors of 2 and 6, where 2 is prime, and 6 can be broken down into 2 and 3, where 2 and 3 are prime. So the prime factorization for 36 is 2 times 2 times 3 times 3. These are all of the factors that multiply together to get 36, where those factors cannot be broken down anymore. We can also find factors of 36 as 4 and 9, or 6 and 6. Okay? So let's use this factor tree to find all of the positive factors of 36. We'll start with 1 and 36. We know that 1 times anything is just itself, so 1 and 36. 2 divides 36, and so that factor is 18. 3 divides 36, and that factor pair is 12. 4 divides 36, and that factor pair is 9. And finally, 6 divides 36, and its factor pair is 6. Let's do the same for the number 24. So again, we can find all of those factors by constructing a factor tree, but instead, let's see if we can just list them. I know 1 divides 24, 2 divides 24, 3 divides 24, 4 divides 24, 5 does not, 6 divides 24, and that's a product of 6 and 4. So I know that 3 times 8 is my next factor, 2 times 12 is my next, and finally 1 times 24. So these are all of the factors of 24. For number 2, I want to find the greatest common factor of 24 and 36. In order to do that, I'm going to find first what common factors they have. So I see they have 1 in common, they have 2 in common, they have 3 in common, 4, 6, and 12. So the greatest of these, the greatest common factor that they have, is 12. Now let's find the greatest common factor of 18 and 33. So let's start by finding factors of 18. Factors of 18 are 1 and 18, 2 and 9, 3 and 6. Factors of 33, 1 and 33, and 3 and 11. So from this list, we have to find which factors are common factors. Well, 1 is always going to be a common factor. And we also have 3 as a common factor. So the greatest of these is 3. So now let's talk about factoring polynomials. Factoring is the process of reversing the distributive property. It's similar to dividing, or like reverse multiplication. It's like reversing the distributive property. It's called factoring because factors are part of an expression that are multiplied. So therefore, factoring turns a simplified expression into a product. So what does that mean? Let's take a look. On the left, I can see the example for the distributive property, 5 times the quantity 2x plus 9. In order to multiply this 5 into this grouping, I have to multiply it by every term inside that grouping. So I'd be multiplying 5 times 2x, and I would be adding that to the product of 5 and 9. Well, 5 times 2x is 10x, and 5 times 9 is 45. So the simplified expression is 10x plus 45. But suppose I want to go in reverse. I want to factor this and end up at my original 5 times quantity 2x plus 9. Well, we start with 10x plus 45, and we have to consider the GCF of each of those terms, or the greatest common factor. Well, factors of 10 would be like 1 and 10, and 2 and 5. Factors of 45, we have 1 and 45, not 2, 3, and 15, and 5 and 9. So of these, we have to consider which factors are common factors. We have 1, and we have 5. So the greatest common factor for 10 and 45 is 5. So we can rewrite, I'm going to just rewrite this down here. We can rewrite 10x plus 45 as a product of those factor pairs. So 10 is equal to 5 times 2x, and then 45 we can rewrite as 5 times 9. And now both of these have 5 times something. So we can write this out as 5 times the entire grouping, everything that we're multiplying by 5. So 2x and 9. And now we're back where we started. Another way you can think of this is, well, we're factoring out the GCF, so that's going to go in front of my grouping. What's left inside is that division. So if I were to take my original divided by the GCF, then I would have 10x divided by 5 plus 45 divided by 5, which, as you can see, 10x divided by 5 simplifies to 2x, and 45 divided by 9 simplifies to 9, or evaluates to 9. So we get the same answer either way. Whichever way you want to think about this, as pulling out that factor in multiplication or by dividing out that GCF, it's a similar process. Okay, so let's take a look at a couple ways to find the GCF. So let's find the greatest common factor of these expressions. 1a. Find the GCF of the quadratic trinomial 2x to the second or squared plus 6x minus 10. We can do this by finding the prime factorization of each of the terms. So 2x, the prime factorization is 2 times x times x. 6x, the prime factorization is 2 times 3 times x. And finally, the prime factorization of negative 10 is negative 1 times 2 times 5. Now we can find all of the common factors that all three of these terms have in common. So if you take a look at each of these prime factorizations, what do each of these have in common? These each have a factor of 2 in common. And that's the only thing they have in common. So that's our greatest common factor. For 1b, we have x to the 7th plus x squared plus x to the 4th. So we have x to the 7th is x times x times x times x times x times x times x. X squared is, of course, x times x. And x to the 4th is x times x times x times x. So we can find all the common factors that these have, all three of these have. So we have 1x, we have 2x, or 2x's, and that's it. That's all that they have in common, that all of them have in common. So our GCF is x times x, or x squared. Finally, 1c. Now we're going to do this without writing out the prime factorization. 8x to the 6th plus 4x to the 5th plus 20x to the 4th. Well, numbers with numbers, variables with variables. Let's first consider the GCF of 8, 4, and 20. The GCF of 8, 4, and 20, well, I see that all of them are even, so I know 2 divides it, but let's check and see if 4 divides each of them. I know 4 divides 4, 4 divides 8, and 4 divides 20, so 4 works as well. And because that is one of our numbers, that's going to be our greatest common factor for the numbers. Now let's consider the variables. We have 6 x's in the first term, we have 5 x's in the second term, and 4 x's in the final term. So out of all three of these terms, how many do they all have in common? The answer is x to the 4th. So our GCF of this trinomial, the 6th degree trinomial, is 4x to the 4th. Okay, let's practice finding the GCF. So for A, we have 9m plus 15. So I'm looking for factors of 9 and 15. What's the greatest of those? The answer, 3. For letter B, w cubed plus w squared plus w. We don't have any numbers in front, so we can assume for each of these it's 1. Doesn't make much sense for us to pull out a factor of 1 because that's not going to change anything. So let's consider the variables. How many w's do each of these have in common? The answer, 1. So just w. For the next one, we have 2b cubed plus 4b to the 5th plus 5b squared. The numbers with numbers, so greatest common factor of 2, 4, and 5. Well, the greatest common factor of 2, 4, and 5 is 1. these numbers are considered to be relatively prime. So let's look at the variables. B cubed, b to the fifth, and b squared. What do all of these have in common? They have two b's in common, so b squared. And finally, letter D, 4yz plus 10y minus 8z. Numbers, so I noticed that each of these, the greatest common factor is 2. And then yz, y, and z, well, there's no variable that all of them have in common. Not all of them have y's, and not all of them have z's. So we cannot factor out any variables. So our greatest common factor is just 2. Let's get some practice. So now let's go ahead and factor 8x minus 22. We're going to write the GCF in front of the grouping, in front of the parentheses. So numbers with numbers. The greatest common factor of 8 and 22 is 2. And now I have to consider when I divide out 2 from 8x, what's left over? We have 4x. And when I divide out 2 from negative 22, what's left over? Negative 11. We can check this by redistributing back in and see if we arrive where we started. So distributing the 2 back in, let's see if we get where we started. We get 8x minus 22, and yes, that is indeed where we started, so we did this correctly. Example 2, I'm looking at the coefficients 2, 3, and 4. Those are relatively prime. The greatest common factor is 1. So let's look at the variables. xy, x squared, and xy squared. I notice that each of these have at least one x, but not all of them have y's. So our greatest common factor is x. When I divide out x, what's left over? Well, when I divide x from 2xy, I'm just left with 2y. When I divide out x from 3x squared, I'm left with 3x. And when I divide out x from 4xy squared, I'm left with 4y squared. Let's check by plugging it back in and distributing. So distributing this x into each of the terms in our grouping, 2y times x is 2xy, 3x times x is 3x squared, positive, and 4y squared times x is 4xy squared, which is indeed where we started. All right, 2 more for us today. Number 3, factor w cubed plus 2w squared plus 6w. Well, I noticed that each of these have a w in common, so I can factor out a w. And also I noticed that, well, the number in front of the first term is 1. That's our leading coefficient. 1, 2, and 6 are relatively prime, so there's nothing that we can factor out in that regard. So what's left over? When I factor out a w from w cubed, I'm left with w squared. Factoring out a w from 2w squared, we're just left with 2w. And then factoring out w from 6w, we're just left with 6. Finally, example 4. We've got a lot of numbers and we've got a lot of variables. So let's take a look at the numbers. So 6, 9, and negative 21. The greatest common factor, and I'm actually going to use a different color here. So 6, 9, and negative 21. The greatest common factor is 3. Okay, now let's take a look at the y's. So we have y cubed, and y cubed. The greatest common factor, all of these have 3 y's in common. And you know what? I missed the x's. I just noticed there's an x in the third term, but there's not an x in either of the first 2 terms. So because there's not a common x in all of the terms, we can't factor one out. So it's okay. And last, we have our z terms. So we have z cubed, a z, and z squared. The most that we can pull out of all of them is just 1 z. So what's left inside? Okay, so here's our grouping. When I look at the coefficient, when I divide out 6, 3 divided by 6, I'm left with 2. When I divide y cubed divided by y cubed, I'm left with just 1. And I can write times 1, or I don't have to write that factor. And so when I divide out z from z cubed, we're just left with z squared. Okay, for my next term, 9 divided by 3 is 3. Y cubed divided by y cubed is just 1. So we can just, we can write times 1, or we can just drop that. And then finally, z divided by z is just 1 as well. So our whole term here factors to just 3. And then finally, plus, or actually, you know what? Negative 21 divided by 3 is negative 7. So I'm actually going to write minus 7. We have an x that hasn't changed. We didn't factor that out, so that stays with. Our y cubed divided by y cubed is 1. That factors out completely. And then z squared divided by z is just 1z, or z. Okay? So here's our final answer. Let me circle my answers. All right. So this has been factoring polynomials, factoring out the greatest common factor. We're going to get a whole lot of practice on this in class, so we'll see you tomorrow. Have a great day, everybody. Goodbye.